with Mass and Space Systems, but when she's not driving a BMW i8 that's painted like a space shuttle, which if you haven't seen, you got to take a look at, she works with Mass and Space Systems as well as doing media relations for Commercial Spaceflight Federation. So with that, I'll hand it off and we'll jump right in.
Thank you. Quick point of clarification, that is not a Maston purchased vehicle, that is a BMW promotional vehicle to promote STEM, so that was not on my budget. But I'm enjoying having it for a week, and if you want to see it, it's outside. It's pretty cool. But we are here today for Users and Futures of Low Earth Orbit. So it's an exciting panel, and the way I was thinking about structuring this a little bit is instead of waiting until the very end for Q&A, today's the last day of the conference. After we introduce the panel and start into the discussion, please feel free to line up as we talk and contribute to the discussion and questions sort of as they come and make this a broader discussion. So very quickly, what I would love to do is allow each of the panelists to do a quick self-introduction, give me a company, and answer for me in your introduction the question of how are you interacting with low Earth orbit at all, if at all. So I'm going to kind of let you guys start off, and then we'll jump into the discussion. So.
All right. So I'm Chris Wake with Spire Global, and we are a commercial CubeSat company focused on signal intelligence, primarily in maritime and weather, and in terms of kind of access or use of LEO today. We've launched 4 satellites to date. This year we'll put up a further 20 in kind of our initial constellation. And yeah, again, focused on kind of providing more up-to-date or up-to-the-minute kind of updates on maritime and weather data across the world. Apparently my mic was off.
Hello. Hi everyone, my name is Ryan Holmes. I'm the CEO of Space VR. We are a brand new startup in San Francisco working on putting a virtual reality camera on the International Space Station so that you all can be astronauts from your couch. How are we interacting with low Earth orbit today? We're not, but our goal is to have we're having the camera on the station in December. So that's how we're interacting.
All right. Hi everybody. My name's Jason Dunn, co-founder of Made in Space. Okay, cool. So I guess you guys probably already have heard a little bit about what Made in Space does. We started the company 5 years ago next month, and with the goal of top level really figuring out how to help people colonize space, but really focused on manufacturing in space. If we can live off the land, so to speak, then we can kind of act like all explorers of the past. We can go to our destination with a tool set and turn our environment into what lets us survive. Our initial goal was to help the astronauts of the International Space Station have the ability to manufacture and to, in a way, be less dependent on Earth and at least resupply from Earth. And then we figured that if that would work, we could also build a sustainable commercial business of building things in space. So this is a picture of Butch Wilmore holding his ratchet. I actually have one of the printed ones here. This picture is taken 2 hours after we send the digital data to the 3D printer on the space station. So 2 hours after the digital file is sent to the space station, astronaut is holding the physical part in his hand. You know, I think to me, that's really amazing. The idea that if Butch were at Mars, the same would have been true. The time difference not much, and we're actually, I'm going to head back to the office right after this because we're getting ready to pack up the next 3D printer for the space station, and it flies up later this year. And while this is has been a very wonderful collaboration with NASA, it's a technology demonstration, and we're learning a lot about how to make 3D printing work in zero gravity. We're taking all those lessons and we're building a commercial facility that will be used both by NASA and commercial. So everybody in this room has the ability very soon to send hardware to space as quickly as we sent a ratchet to Butch. Yep. Thanks.
My name is Jahan Thanga. I'm with the Arizona State University's Space and Terrestrial Robotic Exploration Laboratory. So we're in fact a research laboratory as opposed to a company. We work on enabling technologies for low Earth orbit and interplanetary exploration. So we have quite a diverse portfolio of technologies that we work for that are sort of focused for LEO and even GEO. Ranges from everything from in-orbit servicing technology, particularly docking capabilities and constellations, to next generation inflatable antennas for comms as an enabler for small CubeSats, to be able to communicate high bandwidth, rich data, rich science data particularly. And then on the third front, we are now actively involved in building a CubeSat centrifuge, which will be sent out into space by 2016. This will be the first time we will be operating a CubeSat or any spacecraft as a centrifuge. This would be a laboratory platform in which we will be carrying crushed meteorites and potentially other particles or other experiments into the future. And this is to look at the effects of gravity at varying effects. So this early stage experiment will be at 0.001 G. But we have a pathway for extending this capability to go for between 0.3 G and 1 G in a future mission. Thank you.
Awesome. So your companies and research organizations are sort of on the front lines of expanding Earth's economic sphere and working towards that. And as we look at this market through this conference in the last 2 days, I've heard phrases like bubble, I've heard phrases like we're, and I've heard a difference in opinion from we're about to be there and we're already there in terms of having this as a real market. So I want to understand what gives you the confidence in LEO as an important destination to expand our economic sphere, and what efforts are underway today to commercialize that environment?
I would first like to say that I believe the bubble mentality is a little ridiculous at this stage, because space goes on for infinity, and now we have a couple CubeSat companies up there, so there's a bubble. It seems like it comes from the old days when we had like Webband, 1.2 billion invested, total fail, and then we have Pay by Touch, 300 million, total fail. But Planet Labs, they raised the most. Like 132 million. That doesn't even compare to what happened back in the day. So I think the bubble's
Yeah, and I'm absolutely willing to agree with you there. I guess where I'm going with this is we see all of this investment in this environment, and what is driving, from your point of view, that confidence in this as the next frontier to expand our economic sphere off Earth?
So at Main Space, there's probably two focuses that we have, and the first is that exploration it's within us. It's very natural that we are explorers and that we will eventually start pushing the bounds and go out into space. And then when we do that, we need to be able to be sustainable in exploration. So that as we build these technologies at Main Space, we know that there's a future need case. But you can't really build a business around just the hope that the future need case is there. So you have to have near-term business model. And for us, we focus a lot on how do we impact people on Earth, because most of the people that are buying the things you need are here on this planet. So, while there's things that we can do in space, everything that we're printing eventually kind of has a use case here on the planet. Whether it's building things for space that a CubeSat, for instance, that we can assemble on the International Space Station and deploy, or building something in space that could only be manufactured in microgravity and then bringing it back to Earth. And I think actually, if you look at every company right now that's raising money, it's because they have a real product that people on Earth need.
So Deborah touched on this a little bit in her keynote as well. I think that part of the shift is actually around the approach to the market. So the technology is there, the opportunity is there, the need is there, and part of what we are seeing right now, I think, within NewSpace is a shift around how you frame it to the outside market, to the consumer, the person who's actually buying it. And so on the consumer side, you think about data from space. They don't care where the data comes from so much as they care that it's reliable, that it's consistent, and that it actually serves a need. So one of the things that we've at least focused on for sure is that while we say to folks like those of you here that we're a commercial CubeSat company, we're a data company. We're all about the data that we can actually get from those satellites that we put up. So if we can do that on a consistent, reliable basis, and we can serve a particular need, then it's all about how we frame that to the outside consumer around their issue or their need for that data.
I think I wanted to add, apart from the the business factors, there is also a technical pipeline that's required. A technical pipeline, both of sustained innovation and being able to sort of continue that over the years and show steady progress, and that in the end sort of builds confidence. In addition to sustainability in having new and young people come into the field. And that was a major challenge with aerospace for quite a while. And so those two things are I think, what can drive new ideas, a pipeline of innovation, and the economics has also got to be conducive.
Right. Okay. So I want to pick up on the challenges and also on your note of the reliability that's required to continue with this progress. So in an ideal world, you finish building a spacecraft or a payload and it launches that afternoon or the next day, and it's frequent and reliable. In reality, there are uncertainties there. Uncertainties can be cost drivers. And what I'm interested in knowing is, what are the biggest obstacles facing you today from either the launch vehicle market, or what are those challenges to get to LEO right now from you as a tech developer?
So I'd say there are a couple. So you mentioned launch. Launch is obviously one that's kind of out there. It's the elephant in the room. I think that the timelines within which launch providers currently work today is very different than our timeline. So our designed to development to deployment schedule is measured in weeks, where launch schedules are measured in years. So getting to a point where you have kind of more frequent and consistent launch opportunities and the ability to kind of book something very quickly in order to deploy is certainly something that I think is going to help move things along. But even then, if you look at kind of resiliency in a network like a CubeSat constellation as opposed to resiliency in a single satellite, so you have kind of all these failure, whereas for us, we get the reliability through the resiliency. So the fact that we can quickly deploy new satellites and the asset network as opposed to any individual unit within that network, resiliency within it. So we can continue to deliver data even if 1, 5, 10 satellites fail at any point in time where you have a launch anomaly or something along those lines. The reality is that space is hard and it will continue to be hard, but part of kind of how we're approaching the market is through using tech that is more readily accessible and then continuing to launch more satellites in that network kind of approach.
Yeah, I would, to add to that, I would say at least my recommendation is hopefully what our story at Main Space can tie into some other people doing similar work at the National Space Station. So to avoid having these troubles of what will be our roadblock to get to space, we've been working from like the very, very beginning with NASA to understand like potential roadblocks and then to be ready to overcome them. Launch to ISS, I think, used to be a much bigger problem than it is today. Now it's pretty frequent. The challenge today is crew time. So if anybody at NASA ISS will say crew time is the big challenge. There's just not enough of it. So we worked with NASA from the very beginning to make sure that the printers are just really low amount of crew time. So we still want to make sure that there's some crew time. We don't want it entirely robotic because we want to help say like it's useful to have astronauts in space, but it's really, really simple amount of time needed. So it's essentially astronauts are there to remove parts, to do maintenance, But we control the entire printer from the ground.
So this is sort of, and enlighten me because I'm not familiar
Yeah.
with the whole process of how you are additively manufacturing. So can an astronaut simply, you're uploading the file and then it's,
Right.
you know,
So
the printer
there-
is receiving it, and is this a button pushing and, you know, back to the cupola, or is it?
That's a good point. So there's Astronaut has the capability to actually entire printer. The printer is itself like a computer. It has it has a monitor. They can control it, and they could put their own file in and print with it. And but that will take more time. So what we do is we have a complete downlink and an operations center at our office code at Moffett Field, and we control the printer there. So the joke I always say, well, it's not actually a joke, just the funny point is that if you want to send hardware to space, you can go to Cape Canaveral, or Vandenberg, Wallops, or there's this room at Main Space where if you put a jump drive into the computer, we can send the file to space. So, and that was all designed with NASA and, you know, working with them to figure out how do we avoid potential roadblocks. Like
Right.
the fact that if you don't have crew time, you're not going to use the printer.
Right, which brings up a great point for the whole panel, as government as a catalyst to commercialize low Earth orbit. And as in a research institution environment, I mean, I guess that you're working with NASA almost primarily as you go through, you know, the entire roadmap of these technologies, as you mentioned. So what efforts have you experienced from government that are helping commercialize this environment?
There are a whole sort of suite of programs that are coming through. And I would say, you know, we're not tied to NASA almost exclusively. And so what we have been sort of planning and sort of executing is diversification. Diversification both of launch opportunities, of funding opportunities, particularly trying to partner with commercial entities at early stages, help, you know, drive innovation and drive early stage research funding. And on the NASA side, you know, there's great programs that are out there. I can, you know, sort of mention the NASA CubeSat launch initiative, and then there are several others planned. But there's still in the government side, I would say there's still some artificial barriers. For example, there's launch opportunities which is separated from funding opportunities for those missions. So typically researchers will have to either first get a funding opportunity which doesn't actually pay for launch, and then they have to go off and then look for a launch opportunity. So these are, in a sense, artificial barriers that could be you know, readily overcome. The Air Force has more streamlined in that respect. Other agencies are definitely getting into this, and it is coming down to a price point. It's not just you know, government agencies, but foundations, and I would say independent research institutes that can you know, sort of readily fund projects of this scale, but certainly in a more focused or in a thematic goal.
Right.
As far as challenges going, our biggest challenge and our largest spend is on interfacing with NASA safety. So the reason all these web companies are so successful is the barrier is $10 to get on a DigitalOcean instance or like an Amazon Web Service. But right now, it's really wonderful that we have SpaceX lowering the cost to like $1,000, hopefully $100 a pound. But and if you have this massive $250,000 plus spend just to go through a safety board, I mean, you're not going to get that internet innovation anytime soon at that rate.
Yeah.
One other comment, actually, on challenges. I can't believe I missed this one, but talent. Space is sexy. It has sex appeal to it. But the reality is that today we're actually competing against more of the Googles, the Facebooks, the Teslas, and others who are out there doing equally sexy things and kind of pushing the bounds within their own in space. And I think one thing that we found is that we actually get more non-traditional engineers or engineers coming from very diverse backgrounds who approach this in a completely different way and end up kind of pushing us ahead much faster than we would have had we used kind of the traditional models within aerospace, I'd say. So finding additional talent and kind of promoting space does have opportunity both for growth within the organization, for personal development, and then we're kind of pushing the bounds of what is possible. I think is a big one that we collectively as a group can kind of promote more of outside.
Last week we were at the ISS R&D conference, and I would just like to give a shout out to the Cases folks because they were really amazing, and now it's easier to be amazing now that we have like a funded company with like 8 people. But back in the day when it was just me, they were still amazing. They were very encouraged, and that was part of that's definitely a key component in having that kind of encouragement and willingness to work with people at the very beginning. It's very encouraging.
Yeah, that's a really good point. So sort of efforts that from CASIS, from NASA STMD's Flight Opportunities Program that you guys had a great experience with, and these efforts to sort of integrate younger companies into LEO, into the space station environment. What more can agency be doing to commercialize this effort? And how, as an industry, can we make sure that once we're past the that's not an option anymore, that we still have a viable non-government market?
So I really like the way NewSpace worked with NASA in how we did our tech demo, the printer that's on station today.
Right.
And I think this was a little non-traditional in how it came about. So this was it was really like a collaboration. So NASA did their chunk, NewSpace did our chunk, and together it wouldn't have happened unless both kind of like split up the pie the way we did. So we came in saying we know how to build a 3D printer for microgravity, and let us be the expert in that. NASA came in and said we know how to take something, a brand new piece of hardware for space station, and take it through safety, and we can install it and do all the review process to make it fly. And then together we made it happen. And NewSpace learned a lot, and now we've built up a skill set. So like with the current printer, NASA's not taking that role anymore. NASA's handed that off, and Made in Space is completely running the show to fly the printer. And it's because, in a way, we like built up the expertise in the company working with NASA.
Right.
So I think if we could replicate that model, and if other companies could come into NASA and say, we want to put this type of technology in space, and NASA could actually help make the first one happen, I think it would. I know it built up a lot of expertise in our company, so I could see it.
Right, and it
being
acts
really
as a
great.
catalyst, right? I mean,
Yeah.
you work with NASA, you develop this capability, you have it in the station, and then you have a commercial company like Space VR that can come to, hey, we have a totally, business that we know we can utilize this space, and the inroads are already made
Yeah, so what
commercially to create this ecosystem.
So what Kelly's kind of alluding to is, so Space VR is one of the first commercial users of the printer once we get commercially operating. So you guys will be able to get hardware to space really quick and meet your needs. And we're doing that across the board with a bunch of really cool
Right.
projects.
Which is, and that goes back to the creation of the sustainable ecosystem that eventually will
Yeah.
last beyond government presence.
Yeah, and this went like really fast. So it was, just to give the history there, was like March 2013, we kickstarted the flight program for the first printer with NASA. By 1 year later, March 2014, delivering flight hardware. We went through that kind of the typical long road to get onto a launch vehicle after you deliver flight hardware. And then we were operating at the end of last year. And now, less than a year later, we have commercial users signing up. We have the commercial facility flying. So it was like a really fast amount of progress.
Right. Let's take a question really quick.
I was hoping to go back to, Chris, what you were saying about talent and some of the challenges. We run a networking group in Seattle called Space Entrepreneurs, and we're looking at kind of the Boeing ecosystem and the Microsoft, Amazon ecosystem, and trying to bring them into the fold. What people are responding to in terms of, we kind of look at it as people aren't aware of what's happening. maybe you have people who are software engineers who are interested in space but aren't really, again, aware of the opportunities. And I mean, thankfully, NewSpace is coming to Seattle, and we hope that will raise that. But in terms of getting these other ecosystems into the fold, what are you seeing people respond to talent-wise?
So part of it's awareness, but I think within awareness, it's not just telling people that there are new things going on, but also kind of laying out that there are changes in just simply the way it's done. So for better or worse, there have been stigmas around kind of old aerospace and the idea that you have to work within a particular company for 10, 20 years before you get to manage anything. And that if you're working on a project, you could work on it for 5, 10 years and never actually see it fly. So in reality, I think that part of it is educating around the fact that things are changing, timelines are getting shorter. There are development opportunities and kind of opportunities within the company. I think the same kind of benefits that you see from someone like a Facebook, a Google, an Amazon, a Microsoft, where you can kind of work on new cool things and you can switch roles if you want to. Kind of that personal and professional development piece of it is a big one that we've seen. So for us, there's a big focus on kind of giving people the opportunity to say, I get up in the morning because of X, Y, and Z, and then trying to find a way to align their individual role with X, Y, and Z so that they actually feel like they're making a contribution to the greater whole, and also they're personally kind of, I guess, invested in what it is they're doing on a day-to-day basis.
And things like salary, we mentioned Google and Facebook, and I mean, those can be kind of offset, those concerns.
Those are kind of offset. So I think that there's, what are people optimizing for? At the end of the day, some people are optimizing for cash in their bank account. Some people are optimizing for opportunity. I think what you see now with a lot of the younger generation is that they're actually optimizing more for opportunity than they are for cash. So if they have an opportunity to work on something truly meaningful that can make a change, and they feel like they're doing something that actually is helping push that forward, they're not just a cog in the wheel, they're going to be more likely to come on board. And again, space is sexy, so there's some sex appeal just in working in space in general, being an explorer. So I think that, for us, one of the big differentiators has been playing up the fact that you work in space, but then backing that up by actually showing people that we're not just giving you something flashy and then replacing it with, the rigorous 10, 20-year cycle. We're actually backing it up with kind of development opportunities and kind of those cool, unique projects that continue to come.
Thank you.
I should add that with the times, particularly with the growth of NewSpace, is the role of universities in helping to catalyze some of these capabilities. So one is, changing university programs that enable multidisciplinary education that, transcends not just your traditional engineering fields, but, pulls in sciences and then pulls in the economics and technology transfer skills. And so our efforts at ASU has been still somewhat early stage, but it's been looking at things like the NewSpace Institute that would be a conduit for interacting with the NewSpace sector, with universities and then government collaboration. We're still in the pursuit of figuring out how to do that. The other is through catalyzing startups, both through that leads from student projects, master's thesis, and even PhD project. And what we can do better to better streamline this process. And so of that equation is what can government agencies in a sense match and help, particularly for giving students a leadership role as early as possible, or give them the chance to try.
Yeah, that's a good point. Let's take one more over here.
So since most of you are working with or have worked with NASA in one form or another, if you could change one thing about that relationship, either the way you work with NASA or what NASA does to improve the process, what would you want to change?
Yeah, I think you have your answer.
It's perfect. Yeah.
Yeah.
Perfect. I don't, there's always like just in any time you have a relationship with, it's like two groups working together. There's always the little things that you can learn from and say we should do better on that next time. There's not really any big complaints. I know there's probably looking back on the past, there's been kind of syncing up on marketing has always been one thing that we've had to do a lot with, and I think that's natural. Like if it was two companies working together, the same would happen. But two groups doing something together, and we both want to sync up on how we make announcements.
Right, one accounting to players and one accounting to investors.
Right,
and,
so you have to
right.
you have to tell the story correctly both ways. And I don't know what you could do better there, but at least just knowing that being prepared for that. And then I'm trying to think with our current mission, we're going through the qualification phase. So our printer that's flying later this year is about ready to go through qual, and we have. We're kind of just working with the schedule of all the other things going through different qual and different facilities, and just making sure that we get what we need so that we can stick to the manifest that NASA's giving us. And but that's that's more of just a huge schedule where there's somebody on the NASA side trying to manage a lot of stuff at once. I don't know if there's anything that it seems like it could be.
I think that I know that the people at NASA are extremely well intentioned, and they've been working at NASA. The people that are on the State Review Board and things like that for probably longer than I've been alive, and so that kind of endurance is just really commendable. And so they're extremely well intentioned. I think that they would benefit from just completely automating the entire process, so that you can log into a web app. Potentially with Facebook, that's probably asking too much. But and just see everything you need, and just check off every box, and just go through it and start, so that you don't have to talk to a single person. That would be ideal. I don't know.
Spoken like a true engineer. Awesome.
So,
I should add that in the current space sphere, I would say the competition is certainly increasing, and we're seeing the rise of new space nations that have sort of come out of left field, and they are showing some of the innovation that can come out in very short order, and part of that has been sort of playing the equation is do you completely reduce down risk at the price of culling innovation, and it seems like on the NASA side we may have dialed back too far, and we can see examples from other nations of how they have accelerated and managed to do so at much lower cost, and I would say comparable reliability. To say that this is indeed alternate pathways, that's something that we can try to learn from, and sort of further encourage innovation, and NASA to sort of further interact with its university and its commercial counterparts on the commercial crew vehicle idea is a big open doorway to that whole approach, but do the same in other areas, particularly things like trying to catalyze in-orbit servicing, which has been sort of floundering over the last 10 years or so.
Yeah, that's a good segue. I'm going to get to you in
Can
one
I
minute.
just add one
Yeah,
more? I think this
by all
is a
means.
really good a good thing that I've been thinking about. So, like to date, MainSpace we've never taken investment. Like it's kind of strange. We live in Silicon Valley. We're next to Sand Hill Road, but we don't go there, and we're not taking investment. So when our funding cycle is tied to like an SBIR program or a NASA grant program, it's our funding cycles are like 9 months out. It's like we propose something, and then it's like maybe if we're lucky in 9 months, the money starts coming in, or at least in 9 months, if we're lucky, we learn that the money will come in. So it's really hard as a startup to kind of plan a roadmap where you have to be thinking about, okay, in 1 year I'm going to need money, so I need to start trying to get that money now. Whereas I could go down the road and get a check today. Like I could just walk and there's investors that have come to us and said, we'll write you a check today. So I think I've always been trying to think how could that be made better just on the government side to help, when it's a startup and money is really important to survive, how to help make that happen faster. I've always imagined how cool it would be if instead of writing proposals, NASA or just any government agency had pitch days, and you just go in and you just pitch, and then you get a check that day. And there's just like, it seems like they have a pot of money, and they're like, okay, we're going to give all this money away today to our top 10 favorite pitches.
So you don't want to talk to anyone, and you just want to finish it the same day.
No, I would second the
I love it. I love it. I mean,
NASA
this is
Ventures.
Yeah, totally. And I want to, before we get to you guys, just bear with me for 2 minutes. I want to go, looking at the current users of this, I think you're making a really good point insofar as you have a vision, you have a capability that is in the process of being brought online or up to space, creating value today for your customers, sustain yourselves through that. I mean, I think Spire is a great example, right? You have a maritime data that is an entire half of your business as you work to the Stratos end. So what has been some of the trade-offs there, and how are you augmenting your sustenance here on Earth while you pursue space VR, or printing off-world, or right now you've got Butch, who is currently one of the only off-world manufacturers. What can be done to augment that as we reach for LEO?
Well, for us, we can generate a ton of content on Earth.
Right. So as sort of like a business model, for people who might be also having, business ideas of something that could be done in LEO, and that's the goal, that's the destination, but along the way, creating value for your market here
Like in the next
first.
2 weeks, we're going to be doing a live balloon test. So we're going to be setting up a VR camera on a balloon. And so that's kind of cool stuff that we can do, and we can put people at every single major launch in the world being able to watch that in your house. And then
Well, speaking of which, you have a toy over here.
Yeah, let's see this. Yeah.
I mean, I guess if you want me to.
This is what it looks like when Ryan puts a helmet on his head.
So anyway,
It's
Well, I'm
happening.
super curious,
Totally.
so this is a VR headset, and
So explain to us how it works, and it looks like you have a cell phone attached to the front.
You're correct. Yeah. So this is a Samsung Note 4. It's a basic, massive cell phone, and you just put it in this. This is about $250 at Best Buy, and so you can go buy this now. And you just slide your phone in and click in, and it'll auto load as soon as you put it on.
It is very cool. I just watched a SpaceX launch before the panel in VR.
The SpaceX 7.
It was.
Cue the plug.
What's that thing over there?
Yeah, so if you guys want to come by, this camera right here is our prototype camera. It's called the Overview 1, based on the Overview effect. And we captured the SpaceX 7 launching, and I was super, super confident on the way, telling everyone how successful the mission was going to be. And so that was a little surprising. But you can watch the unfortunate event in VR at our booth right next door if you'd like. But back to this. This is a Samsung device made in partnership with Oculus. This is the best VR headset out for consumers right now. And so all of our content, we're platform agnostic, but we'll definitely focus on space. Is such an amazing experience. It should be experienced on the best quality device.
And let me reframe that question a little bit before you go back to you, because I'm curious with Spire in particular. So in bringing this capability online, are you finding that there are other markets that you were surprised that are now markets that can utilize this space that maybe you hadn't, that are not aerospace companies, for example? Or is it also driving innovation in customer terminals, like the predictive analysis tools or, the end solution on the ground? Is it a symbiotic relationship there in development?
Yes. So I guess there are two different areas of surprise, I guess, that we had as we kind of dug into things. As you started to look at, for instance, the maritime market and what that looks like, it's a rabbit's hole of opportunity. And kind of what we started to find is that there's a lot of enterprise kind of folks out there who simply did not rely upon existing technologies that are in the market today because they didn't get the consistency and the reliability that they wanted. So when you start to think about today's technology, for the most part, it's kind of like a snapshot in time. You have a picture of kind of what's going on. Well, not an actual picture, but essentially a picture.
Right.
And so what we started to talk with them about is this notion of kind of, as we modeled out the network, what the network of satellites could provide. And instead of a snapshot, you start to get an actual moving image. So you have clear trajectories of where things are going and where they're coming from, who's at fault in case of, say, a collision or an oil spill. You start to get, greater understanding of how certain ships are actually using illegal fishing practices in areas where they shouldn't be doing it, because you can clearly see trajectories of where those ships are going and whether they're trawling versus doing something else. You start to hear from certain governments, well, most governments, with any coastline, that they want to have a better understanding of who's coming in and out at all points in time, whether that's for maritime security, search and rescue, trade monitoring, all these different things. And so as we started to dig into it, all these different kind of new verticals, I guess, came out of the woodwork, but all reliant upon the same single data source, which is this clear understanding of where all ships are at all points in time. On the flip side, when we started to talk with people about just the core technology behind what it is we do, this idea of signal intelligence and software-defined radios, it became very evident that there are a lot of other opportunities in the marketplace. Everything from tracking endangered species who are already tracked with tags, but not necessarily tracked from space or tracked across wide distances where you don't have coverage. The Malaysian Airlines tragedy was something that kind of caught us off guard, but when we started to dig into it, you realize that plane tracking, and I apologize for anyone that's traveling overseas especially, plane tracking is not what it should be today, and there's not a clear understanding of are in the sky at any point in time. So the same thing that applies to ships applies to planes. As soon as you get kind of roughly 50 miles off of the coastline, you're more or less disconnected from the modern world. And that was a reality that we didn't think was feasible in today's kind of modern world, but it is what it is. And it goes back to kind of Deborah's point as well, that people don't necessarily think about where all this data comes from, but it comes from space. And we simply haven't had the right kind of technology available to us in the right format, specifically going back to the value of LEO, being able to launch these kind of constellations that can provide you with this truly global coverage in the past. And now we're kind of seeing that come to light.
Wow.
Does that answer your question?
Yeah, absolutely. No, it's exciting to think of all of the other markets that can benefit from reliable access to low Earth orbit. Did you want to add to that?
I can go quick. I want to make sure we get to more
Yeah.
questions. So we think of ourselves much more than just a space company, and I think that's, I kind of hear that in the way Chris is talking about Spire, like you're like a data company and all these other things, and I think that's really important to keep that in mind. So for us, we build the world's most rugged and reliable 3D printers, hands down. Like you can put it on a rocket and it survives launch, and then it turns on and prints right away. You can go in an airplane and go up and down in parabolas. So for us, is where else are there cut-off supply chains where manufacturing is needed and you're in a remote or rugged environment? So so there's so many other applications for the technology we build, and we can use that to help move forward the initiatives for space.
Right, right. And all space exploration starts right here on Earth, so it's a good point.
And we are looking at dimensions which are underserved at the moment, or that have been that have emerging holes because of lack in service. So that is cryosphere monitoring, and the limitations of the number of satellites available. The other is space weather, which can have critical implications to our connected world, and the next generation of technology that can try to withstand that. In addition to the security dimension, and I would say the traffic and the overcrowding in LEO and GEO. And so all of these are facets of commercial opportunity in addition to fundamental research of getting that technology sustainable or commercially viable before we can see some sort of, I would say, a solid implementation plan.
Right. And I think you were next.
So this is an online question through Questful, and it kind of goes in line with what you guys have been speaking about. What are the key opportunities for new agile companies in LEO, in communications, propulsion, robotics, or other areas?
So this isn't the most concrete answer, but I like to think about how can these new initiatives happen in space using our 3D printers, and that was kind of one of our biggest goals, was that if we could put manufacturing in space, we would open the door to a whole new set of people and organizations and ideas that never could have existed in space before, because the burdens to entry were just way too high. And if we can make the cost cheaper or the iteration time faster, an experimenter now can build an experiment on station, run the experiment, learn from the results, and then design something new and print it. And this can happen in like the time frame of weeks rather than years. So imagine if you're a PhD researcher, you actually do all your research and have this amazing thesis, rather than maybe like going into postdoc and then becoming a professor and still working on the same thing because it takes so long. So we want to like expedite that, and I think there's room for new types of agile ideas and products to exist where when you can remove the long time frame to get things into space. I don't know what the answer is, but we have a lot of people coming to us with their ideas, and we'll help them try it out.
Immediately throw out as well would be sensor payloads. So specifically thinking about what could you do for remote sensing by building something that could go onto a CubeSat or small sat platform. That's an immediately evident one. Obviously, selfishly, we would love to see what you have. And then separately, start to think about applications. So what could you do with truly global kind of data stream coming in every couple minutes effectively? So providing you with kind of that level of data, there's a data analytics side, or even thinking about on-orbit applications. What are the things that you could put on board in order to leverage the existing sensor platform that is there? The same way that, with our smartphones today, the applications we use, if you Ubered here, or if you used Waze, it was using sensors on board your phone. So thinking about that and what you can build on the software side as well.
And we think, one of the underserved sections is on-orbit robotics. And the technology's been demonstrated, but it's one of those unique, sort of commercial challenges that really prevents it from really taking off. Because from how it has been sort of identified now, it's almost an all-or-nothing proposition where you have to get your robotics capability reliable enough that the service providers can sign on to this technology. And before then, before your commercial entities in a sense sign up for these type of services, you really don't have a customer, and so it's stuck in a chicken and the egg problem.
Right. So as these capabilities come online to provide reliable, cost-effective access, you see all of the implications that can be had from the software realm, from space VR, virtual tourism, the armchair astronaut model, to printing, to any number of new tech pathways and applications. You have a question?
I guess in terms of building an off-world civilization, you guys are the tip of the spear. And it's awesome to see you guys, and congratulations for what you've achieved. I think it's amazing. The question I've got for you is, you're all at the beginning of your careers, as far as I can see. Where do you get to in 20 years? Like in NewSpace 2035, what have you achieved?
So in 20 years, we would like to have a VR camera on Mars.
Nice.
Yeah. As well as we're attacking this new section of space, and I would like to tie this in with the previous question about what would you encourage entrepreneurs to do. I think there are things in space that no one in this room has even begun to think about, and that there's a lot of value there, and that new entrepreneurs are in the perfect position to attack that, because they have no attachments to anything. And what we're building out is consumer space, so making space a destination that people can actually interact with for the first time ever. And I think as much as we would like to dominate that entire market, I think there's a lot of value there for people to engineer new ways for people to do that as well.
So in thinking, okay, so this panel is low Earth orbit users and beyond, and that makes a really good point that, you envision your company going on towards Mars and towards other destinations. So in the way that you interact with LEO right now, or are considering it, are you looking at low Earth orbit as a stepping stone or as an ultimate destination, like a terminal orbit for your business? And what I mean by that is, what's in the future for you, and are you using low Earth orbit because it's sort of a minimum viable business case, it's an R&D sandbox, it's the cost-effective means to prove out what you want to do elsewhere? How are you looking at that future and where you want to be as it relates to low Earth orbit?
I'm sorry to have the mic, I guess. We're looking at it as all of the above. So an R&D center, and but we believe that people want to go beyond low Earth orbit. So our core business is to enable what people want, and since people want to go to the moon, we will enable them to do that in various ways.
I think the big question in the next 20 years is, can we increase access? Can we increase and enable students at the middle school level or at the low high school level to have sent space projects, be able to operate missions? And so LEO is the access point. It will stay that way for a long time.
And is that, I guess what I'm getting at, is that all it is? Is LEO a compromise that we're making because of the lack of frequency and reliability and low-cost options to get there? Or is there some unique, end that LEO in itself is a destination that has some sort of unique applications?
It just happens to be that the delta V required for you to go to LEO, even with our the best propulsion capabilities, is very hard, right?
Yeah.
And it just shows that with the numerous rocket launches that it is not.
Right, so it's a barrier to entry kind of thing.
So I'd take a different, approach. I love LEO. I think we'll sit in LEO forever. And I say that because there are a lot of advantages to the way that we approach the business. So specifically, we think about the revisit time, we think about the access time for the data that we can get down, and then we also think about the cycle of innovation that we can put into the satellites that we put up. So for us, one of the big things is that there is a lot of access to LEO. There are a lot of launches going that way. There will continue to be more as more kind of small sat launch providers pop up. Now for us, if we can start to get launches on a more consistent basis, then that means that we can take the Moore's Law advancements that are going on here on Earth, everything that's going into your cell phone and into consumer electronics, this idea of smaller, better, faster, cheaper, and apply that to space in a way that's meaningful for all of the customers or consumers of the data that we're actually getting down from those satellites. So I love LEO.
Just to add to that, there's always a place, I think, why LEO is important. Remote sensing, obviously, a good one. We believe that manufacturing is like the killer app. That there are a lot of things that we can make in space that are needed in space, but also needed on the ground, and there'll be reasons to do it there. But like going back to the last question about where are we at in 20 years, because it all ties into that. I think like
Absolutely.
we believe that anything's possible in 9 years. If we could like in this, put people on the moon in that time frame, then we should be able to do a lot better now. And when I look back at what Main Space did with the first printer and how it was about 9 people at Main Space plus the NASA team, and overall a pretty small team took an idea that had been talked about in science fiction and in technical papers since the 70s, and took that idea of space manufacturing and made it possible in a year and a half.
Right.
So small team and short amount of time took an idea that's been around since before the space industry existed. The question I've been asking myself, like nonstop since we did that, is what could we do as a collective whole? Like if all of us in this room, if the entire space industry worked together on something,
Absolutely.
what's possible? And
I mean, look at it right now. The robot, you can print the landing pad from Mars, you can bring the experience home, you can track the sand dust storm.
I mean, it's about agreeing.
Not sand.
It's about agreeing that we should do that. And, the last time that happened was Apollo. That's the last time there was like a collective whole all said, let's do that.
Do you feel more encouraged today that that's happening as you're at a conference like this and you're able to interact and touch so many different points of business and universities and research centers and entrepreneurs? Are you feeling encouraged that that's where we're moving? Or is there still work to be done to find?
Yeah, so I think we are, and there's a lot of things happening. There's the commercial companies that will exist just to provide benefit on Earth. Like I think Spire, as a company is really important, and it sounds like as a company you want to just keep serving the people on Earth. So maybe, but we need also these people who are saying, okay, let's all collectively put a base on the moon that we can put people on and we don't have to bring them home.
Right.
And we can then use that to learn how to go to Mars and do the same thing there. And everybody in this room wants that to happen. I think in 20 years, this conference maybe is held in virtual reality on Mars because of what Ryan is able to create. So I think we need to be thinking about that. And going back to Moore's Law, like, we need to really be paying attention to the fact that technologies are changing really, really fast. And what everybody in this room thinks is going to 20 years from now will look like, everybody's probably wrong. Like, I don't think any of us know what that looks like, and I would keep that in mind. But
Yeah. Yes, sir.
How far are we from a robust LEO tourism industry? At least a few hundred seats a year.
Virtual or physical?
Very good.
I mean physically there.
Oh, okay.
what does it mean?
Well, I'll give you 6 months on virtual.
I don't. That's not my expertise.
Yeah, so I think to touch on that from what I'm getting from these guys is one of the core foundations there to building up LEO in any sense, whether it's a tourism application or whether it's satellite imaging, is the need for frequent, reliable launch at an affordable price. And the more we work towards, the sooner we hit all the marks with these mass markets that are able to reap the benefits of it.
I think one factor is we have to of our aspirations versus what we can really achieve. And with the Apollo moment, that was one instance of the nation sort of coming together, but it was driven by external threats. In I would say relative peacetime, the differences are we have a challenge of bringing a nation together on a sort of a sustained and focused goal, and ultimately it's the technology that needs to be shown, or we have to have pretty good I would say reliability and sort of sustainability, both financial and research innovation, and not really overpromise. because that can be a turnoff to the wider community. Right?
Good point.
Yes. Earlier, the first day of this meeting, the concept of a gapless transition from ISS to the world beyond ISS, in and beyond LEO, was discussed, and the importance was emphasized. ISS is the 800,000-pound gorilla. It's actually over that. It weighs more than all other operational satellites in LEO put together and probably costs more than them. Okay? How do you see your roles in forwarding a gapless transition to the world beyond ISS in LEO?
Space VR's role will be inspiring the entire population that it's really awesome and that we should do it.
For us, ISS is it's a test bed, right? It's a place. It's a pretty great environment to test out technologies for manufacturing in space. But it also offers, in some ways, it's like the Grand Central Station for space. There's a lot of satellites going through it, right? There's a lot of access to ISS. There's the fact that we have humans there to do a lot of the work for us is really nice, because robotics aren't there yet to do as much as what human hand can do. And I think we need to leverage that a lot. And then keep in mind that we only finished building ISS pretty recently, and it's time to start really using it and to turn it into what of commercialization wise. Like I'm sure we could one day ISS could be 100% commercial if it wanted to be. Like there's definitely a need for that much commercial activity.
Yes.
So one thing that hasn't been discussed is Bob Bigelow, and it was kind of alluded to, but he comes to this with a different set of pockets than you have. Can you talk a little bit about the challenges of being forced to start small and having to scale from that?
Yeah, the quick story for Main Space is we started in 2010, 2011, completely bootstrapping. My co-founders and I, we decided rather than raising money, if we could go to the customer and they wanted the product or the service, that was the right way to go, as with really any business that you should be starting. And looking at all the different customers that would exist for in-space manufacturing, obviously NASA would kind of be the ideal one, and we were able to get on board pretty quickly to start working with us on that. So it was a long road. We started with SBIRs and stretching every penny. So making $125,000 phase one last a lot longer than 6 months to keep employees there, but you make a lot of sacrifices, and the number one goal is always don't die. Just keep moving.
Yeah, I definitely reiterate the fact that customer development is a big thing, so understanding who your market is and getting out there and talking to them as early as possible. The other thing that lack of money does, it makes you hungry. So you move much faster, and it pushes you along because you want to make sure that you're next sale or able to kind of get to that next stage. I mean, for us, 0 to 12 months, or actually less than 12 months, and we went and pulled together the first vacuum in order to kind of roughly test the satellites before we put them up. So it kind of caused us to think outside of the box, and in the end, it worked out. So we've gone through multiple iterations, kind of each step of the way, and focused on kind of getting those milestones that you truly set with your customers so that they have a clear understanding of what it is they're going to get at the end of the day. So be hungry and be fast.
So there's steps to this process. And my first step was selling my car, right? So that you can start at the base. And then the next step would be to have an extremely awesome opportunity. So for us, it's having a unique camera that captures imagery never captured before that you can then scale to every single person on the world with a cell phone. And so when you have to communicate that kind of value to investors for them to want to invest in your company. And then next step for us will be then demonstrating on a global scale that people really love the product. And so we'll be launching a Kickstarter August 15th, along with 20 launch parties around the world to demonstrate that and to show that this is real, and then we can raise more investment to do what we really need to do.
Great. So quick lightning round of questions, just fun off the top of your head. Jehan, what's the most exciting thing coming out of ASU right now that has you really excited about it?
We're definitely interested in outer solar system exploration. So we are doing studies on Europa Cube. We're actively working with our science and engineering collaborators in the next exploration domain, which is the Kuiper Belt, and so that is a whole new world of opportunities and lots of undiscovered planetary bodies to see.
Cool. Jason, coolest thing that's ever been printed in space?
So you heard the Ratchet story. I think that's like my favorite of coolest thing. Actually, the first thing we ever printed in space was a part of the printer itself. So that's the self-replicating machine. It's proving that it's actually a replacement part. We could use that in the printer. So showing that we actually can maintain our own system using our system. And the other day I actually saw the printer that we're flying up to station soon was printing a part of itself to go into the printer. So
that's terrifying and awesome.
Imagine a robot that's like building a piece of itself and then putting it onto itself. Like that was happening the other day.
Very cool. Ryan, in VR, you have a choice. You can go to Mars, the Moon, Europa, or an asteroid. Which one do you choose? Only one.
Europa sounds really cool.
Okay, I agree. Chris, what is the most out-of-the-box application that you've heard of your data being applied to?
Well, Peter was quoted recently as talking about human trafficking, which was a big one. So being able to track and rescue kidnapped children, I think was what he was talking about at the time.
Oh, that's amazing. Okay, cool. If there are no more questions, can we give everyone a round of applause? Awesome. Great job, guys.
Thank you so much, everybody. We're going to take about a 15-minute networking break outside. Please enjoy some coffee and check out some of the exhibits if you haven't already. And we're going to try to start back up again at 11:15. Thank you very much.